Good morning, friends. This section is all about the partial differential equations of first order. So what are the methods for solving the partial differential equations of first order? So there are three methods of solving partial differential equations. First one is Lagrange's method. This method is used to solve the linear partial differential equations. Let me write PDE, the partial differential equations, right? So it is used to solve the linear partial differential equations of first order having two or more independent variables, right? Second is, then is the Charpit's method. This method is used to solve the non-linear partial differential equations of first order having two independent variables, not more than two, the two independent variables. So it is used to solve the non-linear partial differential equations. Then is the Jacobi's method. It is used to solve the partial differential equations having three or more independent variables, right? So these are the three methods to solve the partial differential equations of first order, right? For linear partial differential equations, we use Lagrange's method. For non-linear partial differential equations, we use Charpit's method. And for the partial differential equations involving three or more independent variables, we use the Jacobi's method, right? So let's focus on the first one, that is the Lagrange's method. But before that, it is important to recall what are the partial differential equations and about the order and degree of the partial differential equations. So the definition for the partial differential equations: an equation containing unknown function of two or more variables and its partial derivatives with respect to these variables is the partial differential equation. The unknown function, that is, if I take z to be we always take dependent variable as z. So this z is depending upon two independent variables, let's say x and y. So this is the dependent variable and it is depending upon two independent variables. So the equation containing this unknown function and its partial derivatives with respect to these independent variables. So we can have the partial derivative of z with respect to x, we can have the partial derivative of z with respect to y, we can also have the partial derivative of z with respect to x and y both, right? So the equation containing the unknown function z and its partial derivatives with respect to the independent variables, such kind of equation forms the partial differential equation, right? So how we can write the format for partial differential equation? So the equation of the form f, x, y, which are the independent variables, and then the unknown function z, which is depending upon these two variables, and also its partial derivatives with respect to these variables. So the equation of this form is the partial differential equation, right? Usually we always take z to be a dependent variable, right? Very fine. Okay, let's move on further. These are the examples for the partial differential equations. If you notice that each of these equations is containing the dependent variables and also its partial derivatives, right? These are the partial derivatives. We can also have the second order partial derivative of z with respect to x, also having the second order partial derivative with respect to y. Let's recall order of the partial differential equation. So it is the order of the highest order partial derivative appearing in the equation. For example, in this equation, z is partially derivated with respect to y one time. So the highest order partial derivative appearing in the equation. So what is that highest order? 2. So this equation is having the order 2. It is the exponent of the highest order partial derivative, that is 1. So here it is the degree 1. So definition, it is the greatest exponent of the highest order partial derivative appearing in the equation. If I am having here the exponent 3 and here the exponent 1, the order is definitely 2, but what is the degree? It is 3. We have to take the exponent of the highest order partial derivative, right? So the degree is 3 in this case. Next, some more examples. For this equation, z is partially derivated with respect to x 1 time. So the order is 1 and the exponent for this is 1. So the degree is also 1. For the second equation, the order is 1 and the exponent is also 1. So here also order and degree is 1, 1. So for both these equations, order and degree is same. Next, in the second equation, we are having the order to be 1. And what is the degree? It is, this term is having the power 2, this term is having the power 2, the same. So the degree is 2. Then in the third equation, the order is 1. We have to take the highest of these two, but both are same. So the order is 1. First term is having the exponent 3, second term is having the exponent 4. Which one is greater? 4. So the degree is 4. Easy? Easy to understand? Okay. In the next equation, z is partially derivated with respect to y 1 time. But here z is partially derivated with respect to x twice. So the order is 2. We have to take the highest order. The order is 2. And for the degree, we have to take the exponent of the highest order partial derivative, right? So here it is 1. So the degree is 1. I hope it is very easy to understand what is the degree and order, right? Okay. Next are the very important notations. We always take small p to be the partial derivative of z with respect to x. And we always take q to be the partial derivative of z with respect to y. At the very start of the content, we have taken the format of the partial differential equation to be this one, right? So how can we write this as further? In the general form, it is f, x, y, z. Instead of partial derivative of z with respect to x, we write small p. And instead of partial derivative of z with respect to y, we write small q. So this is your general format for the partial differential equations involving the independent variables, the dependent variable, and p and q, which are the partial derivatives of z with respect to x and y respectively. So this is the general form of partial differential equation. Now let's move on to the example how to form the partial differential equation. So the example is, form the partial differential equation by eliminating the arbitrary constants from the relation z equal to x square plus a into y square plus b. So from this relation we have to form the partial differential equations, but we also have to eliminate these arbitrary constants a and b. For that, if I mark this given z to be 1, we have to differentiate this z with respect to x and then with respect to y, right? Let's differentiate. So differentiating 1 with respect to x first, we get partial derivative of z with respect to x. Why I am writing this sign, the curl sign? Because z is depending upon two variables, right? So it can be partially derivate with respect to x and also it can be partially derivate with respect to y. If the dependent variable is depending upon only one variable, let's say x, then I write dz by dx because it is depending upon only one variable. If it is depending upon more than one variable, then we use this sign. So when differentiating 1 with respect to z, we are using the sign partial derivative of z with respect to x and is equal to, okay, first function derivative of second with respect to x is 0 plus second function derivating first function with respect to x, it is 2x. So we are getting 2x into y square plus b. Now let's differentiate equation 1 with respect to y. So for that we write partial derivative of z with respect to y. Okay, writing the first function, that is x square plus a. And differentiating this with respect to y, we get 2y plus writing the second function and differentiating the first with respect to y, we get 0. So we are getting this to be 2y into x square plus a. Now partial derivative of z with respect to x is nothing but p. And please mark this as equation 2. So p is equal to 2x into y square plus b, and partial derivative of z with respect to y is q. So this is q, and marking this as third equation. So if I multiply second equation with third equation, we get on the left hand side the product pq equals to, on the left hand side of 2 we are having 2x into y square plus b, and from 3 on the right hand side we have 2y into x square plus a. So when multiplying this we get 4xy into x square plus a into y square plus b. And I can use, instead of these two product, it is given that these two product is equal to z. So writing this further as 4xyz. And on the left hand side we have pq. So pq equal to 4xyz is a required partial differential equation of order 1 and degree 1. So of first order and first degree. Why order 1? Because p is what? It is partial derivative of z with respect to x. It is having the order 1. Q is partial derivative of z with respect to y. It is also having the order 1, right? And their exponent is also 1. So we have written the partial differential equation of first order and first degree, right? Okay, thank you. Stay blessed.